Service modeling is a forte of the ServiceWatch product, bringing fast, accurate, and always up-to-date modeling of your business services. Modeling which may then be used to enhance enterprise CMDBs. These accurate models are then used to support service health and performance monitoring, including areas of incident management, impact of events, problem isolation, and root cause analysis. These same models are used to help with the impact of change, both historical changes and the impact of future changes, really enabling what-if analysis for the business services. Let's look at the various use cases for Nebula ServiceWatch. First, let's take a look at the event-driven dashboard. Many events are brought in from multiple sources, shown on the bottom of the screen. These events, of course, color code the business services up above, as well as change their status. Larger business services represent services that have a higher priority than the smaller business services, providing a simple way for an operations center manager to allocate work. Beyond this, we can drill down from an individual business service, from one business service to the event or events which are affecting that particular service. In this case, we can see there's a problem with a SQL server which is running out of free space on the C drive. We might wonder how many other services are affected by this particular event. Perhaps US payments isn't the only one, and we can drill up, performing an instant impact analysis showing all services which are affected by the problems on this particular server. The event aspect of the dashboard isn't the only one, and isn't the only way with which to analyze the services and their status. We might, for example, take a look at all services, cross-referencing them by revenue and number of users. This provides a completely different picture of which services to work on and which ones to prioritize in the break-fix cycle. For example, we can see here that these red services, of course, would require immediate action. That seems pretty obvious since they're high revenue and high number of users associated with them. However, we can see in fact that there's a email service down here which is ranked low on the revenue and user scale and maybe wouldn't be prioritized for any sort of triage. Root cause analysis is also built into the product, specifically with respect to events being correlated to an individual component in a service map. This shows exactly which component's failing or which one has a problem. Could be a brownout condition, of course, not necessarily a complete failure. And on the right, the impact tree shows, of course, every individual component and subcomponent that makes up the entire service map. One of these is, or perhaps several, are having a problem. And we can identify those very quickly with the root cause button, drilling down to exactly which components and which problems are affecting the service by which percentage. They needn't be 100%. Some problems may affect the service only partially, and we'll be able to see that at the click of a button. Further, we'll be able to drill into individual areas of the service. For example, we could drill into the storage path between the SQL Server and the NetApp storage environment, the from and the to here, and take a look at both the network connectivity and the storage connectivity. So we can see the SQL servers riding on this ESX host. We can see the ports are green. We can see no other red alarms or red ports in this diagram. We can quickly check and make sure that the switch providing the network connectivity between source and destination is appropriately configured with the correct software versions and firmware versions and whatnot. And if everything checks out, then we may take a look deeper down and see that based on what we've discovered into the NetApp storage environment, drive C is actually hosted on volume 3, telling us that the original problem of free space, which is masked on C, really occurs on volume 3, and we need to call the NetApp storage admin in to use Operations Manager and extend volume 3 to take care of this problem. This is a very simple explanation and example of how root cause analysis might work in a hypothetical environment, how it lets you drill down to not just the root cause, but drill down to the assignment of the correct person the first time without gathering siloed experts, CMEs, in the network, server, database areas, so on and so forth, to figure out who needs to go fix the problem. This event correlation into an accurate and up-to-date service map is critical for such analysis. Of course, these maps are created in the first place through a very powerful and flexible discovery, the configuration of which is seen here. Discovery is invoked from an entry point. An entry point can be any resource in the data center, any resource in the IT environment, and can be any one of the following types of resources. For example, if we were to add a second entry point for this particular business service, and let's just say, for example, that this would be an Oracle database. We can see here two different kinds of entry points. The first is a user-based entry point, namely the point in the IT infrastructure where they would access an application, a web-based application. The second entry point represents just the database. So that's the configuration of the database, no user interaction here specifically. And this entry point would consist of a host and the database instance name, port, so on and so forth. And it represents a completely different kind of starting point for the discovery. And we'll delete that and continue with the discovery. And discoveries, once they're configured, are automatic, resulting in detailed maps, detailed service maps of your business areas. Maps which can be discovered and run across N tiers and as broad across the enterprise as is necessary to map out the entire service. Of course, there's another powerful use case with regard to the service maps and their components, and that is the history and analysis of changes. Here we can see many changes occurred on June 6th, right around noontime for this particular business service. In fact, rather than just highlighting the changes as we are here, we can bracket these changes before and after with our search bars. And when we click compare, we'll get a before and after picture, a snapshot effectively of this business service. So we can see the service as it exists today. We can see the service as it existed during that, or was modified during that 2-hour period on June 6th. In fact, we can see by the green lines every connection which was newly added, and by the verbiage every new component which was added to the business service. In fact, if we click into our history bar once again and move our search brackets before those changes occurred, we're able to see a snapshot of what the business service looked like before any changes were made. This is a real powerful function for performing not just research, but really historical triage. What happened last Thursday night? Why did my service go down? Why did a component change? What was changed? This feature in the product answers those types of questions. Of course, understanding the components of a business service and how they connect is just one area of importance, but another use case is analyzing the impact that a particular component, such as the SQL Server, might have across the enterprise. What if we need to take the SQL Server down because it requires a service pack that entails a reboot? Who will be affected? Which lines of business will be affected? We can see this at a glance over on the left. In fact, we can get more impact analysis from this particular screen. For example, if we click on UK Intranet, we can see it's dependent on 3 of these components. Or if we click on Order Entry, it's dependent on 5 different components, all related, however, to this one SQL server. So rebooting the SQL server may involve attention to some of the other directly related components. Another way in which we can look at the impact analysis is to select just one component within the map and see which business services are dependent on that one component. We can see here that 4 of them use this particular IIS server. And since only 4 are dependent on that component, perhaps this would be a good one to reboot first if there's a simultaneous reboot required to address issues. And finally, everything we've shown, the service maps, the components, the events and the errors, the impact trees, the relationships between the components or CIs, all of this may be exported in an industry standard XML format, exported perhaps to another CMDB, which doesn't have the ability to discover the relationships between the various components.